Okay, so we're going to talk about rotation a little bit more. So what exactly is a rotation? So if a figure is rotated, how can you describe it? Let's investigate this question. So what I need you guys to do is grab graph paper, and you are going to graph these 2 points. So A is 4, 1, and B is 2, 5. So if you need to pause the video, please do so now. But I've already graphed my paper. And so I have it right here, right? So here's my B, 2, 5, so 1, 2, 1, 2, 3, 4, 5, just double check. And then my A is 4, 1, so 1, 2, 3, 4, and then up 1. Okay, we're then going to use tracing paper to rotate the 2 points counterclockwise around the point 0. All right, so there's your point 0. So let's make our point B and A. And there's my point of rotation. Again, a little dot at the top. So we're going to go counterclockwise. Again, look at the arrow. We're going to go that direction. So I'm going to move that dot to be on this line. So I'm going to go ahead and I'm going to make sure my dot's on my line. And I'm going to have my new points. So notice that A, this one hopefully is a little bit easier now that it's on a graph. Notice that A can be found by going over 1 and then up 4. 1, 2, 3, 4. So this means our new A prime is negative 1, 4. And then our B is going to be found at 1, 2, 3, 4, 5, and then up 2. So B prime is negative 5, comma 2. Okay, what's the next question it asks us? So now what we want to do is we're going to draw a line segment to connect A to O and B to O. So using our trusty ruler. So again, here's our O. We're going to connect these together. And we'll connect these together. And then it says A prime to O and B prime to O. So I'm going to do B prime to O and A prime to O. Okay. And then using tracing paper, compare the lengths and the angles formed by these line segments. Okay. So I'm back up here. So what I could do is I could just kind of draw these around. And an angle is what's in between the 2 line segments. So, so again, notice what's over here. Notice, did the line segments change? No. Did the angle change? So here's our little angle do head right there. And then over here, notice it's the same angle. Okay? So again, we want to try to be as specific as possible. So what do I know? Is I know that this length is the same as this length. I know that this length is the same as that length. So what I'm going to write down for here is I'm going to say that OA is the same as O to A prime. And that means that OB is going to be the same distance as O to B prime. Again, this distance right here, this distance right here. And this little angle, we don't actually know what the measurement of our angle is. Okay, but for right now, we're going to use three letters, and we always use our middle letter. We'll talk about this later on to describe which angle we're talking about, because we're talking about angle O right here, but am I talking about this angle? Am I talking about this angle? Could it be this angle? I don't know. So we want to use specifically 3 letters, so that way I know it's this little triangle. So I'm going to say the measurement, so M stands for measurement. There's my little angle. And I'm going to say AOB, and that's going to be the same as the measurement of angle A prime, O, and B prime. Okay, so again, that's just kind of a little bit specific. Again, we're going to get more into this notation in a couple chapters, so no need to worry too much about that. Okay. So now C, we want to predict the measurement of A to O to A prime. Okay, so we're predicting this measurement right here, right? So we're almost as if kind of erasing this guy so we can kind of just see it and just make a prediction on your paper to kind of see what's happening, okay? But what it kind of looks like is it kind of looks like 90 degrees. So I'm going to predict that this is 90 degrees, okay? So how could I actually know that these are 90 degrees? Well, I could rotate it, okay? So I could rotate this one, so using my lovely rotating form. So again, 90 degrees. So if I rotate it 90 degrees, again, this guy is going to go up here. It should land perfectly onto that line, which it does. So I can verify it that way. I could also talk about my slopes. So I can figure out what is my slope of OA, and then what's my slope of OA prime. So this one is rise, so rise 1, run 4. So this would be 1/4. And this guy is we're rising 4, and we're going 1 the other way. So notice that these are perpendicular slopes, okay? So these are perpendicular slopes, which again equal 90 degrees. So it's another way that we could verify it. All right, so why does it make sense that all points P on the graph, a rotation about this point O, moves it to a new point, right? So why does this happen? Okay, the biggest thing to remember about why this happened is that a rotation, and I'll sound like a broken record again, preserves the distance between all points and the point of rotation. Again, it's called rigid transformations for a reason. So again, it says a rotation preserves the distance between all points and the points of rotation. Okay, and again, this is just to reiterate, when measures do not change, some mathematicians use the term preserved, okay, when we can say the angles are preserved. Okay, again, no lengths change, nor measures of angles. So everything has just stayed the same. Now, things I want to point out, notice that the numbers are pretty much the same. 4, 1, notice it has a 1 and a 4, but the 1 happens to be negative. So notice that the x's and y's switch. So things I want you to remember is that every 90 degrees, the x and y switch and changes possibly positive to negative, positive to negative, depending on the quadrant. Okay, so it doesn't necessarily always change. So notice that the 4 still remained 4 because the y value is positive in this quadrant. Notice the 1 changed because now the x is negative. Okay, so at least one thing is going to change. So if I moved this guy, if I rotated it again 90 degrees, okay, so 90 degrees, I'd be right there. So I'd be at 1, 2, 3, 4, and a negative 1, right? So if I did another one, I'd be in this quadrant. And again, 4 and 1 stay exactly the same, except now they're both going to be negative. So again, it's been it's been switched one more time. So again, every 90 degrees, the X and Y's are going to just switch, and they're possibly going to change from positive to negative or vice versa, depending on what quadrant we are in. Okay, so that's what that question is all about. All right, so let's look at the definition of a reflection. Okay, so we didn't talk about perpendicular lines in this, but you are going to see this paper, this picture, I should say, on your resource page that looks like this, the one that we completed earlier. So it's a little bit clearer than what I have here. Okay. So what it first says, right, is use the ruler to draw 3 dashed line segments from P to P prime, Q to Q prime, R to R prime. Okay. So this is what I'm going to do, is I'm going to use dashed lines. And dash line. And dash line. All right, so I got my dash lines. Beautiful. Okay. So it says, what's the relationship between the 3 dashed lines? Okay, so what we should notice, okay, is that they're all parallel. Okay, so how do we actually know that they're all parallel? So if let's go with Q, since it's at a 0.3. So I'm going to go down. Let's go down to 1, 2, and then I'm going to go over 1, 2, 3, 4. So Q prime slope is -1/2. Excuse me. If I look at R, I'm going to go down 1, 2, 1, 2, 3, 4. So again, R to R prime, the slope is again -1/2. If I go down 1 and I go over 1, 2, P to P prime, again, the slope is -1/2. So these are all parallel. So all parallel lines. So what's the relationship between those? All right, so now let's focus, it says, on the RR, right? R to R prime. Okay, what's the relationship between the line of reflection, which is right here, and this line right here? Okay, well, all we know is R to R prime has a slope of -1/2. So if I look at this line, let's just look to see kind of what the slope is. So if I go up, and I'm going to go from this point and this point. So I'm going to go up 1, 2, and go over 1. So it looks like line L, the slope, is just 2 over 1, or AKA 2. So what do I know is that line L and RR are perpendicular. All right? And again, we can confirm that. I just confirmed that using the slope to confirm that, so that's nice. Okay. All right, so now it says place a point on N at the intersection of R. Oh, perfect. I already had a point right there. Okay. What do you notice about the lengths of the segment? We call this N. Okay. What we should realize, and again, we can use graph paper to see this. So we should see this length right here. What we should notice is this is the same length over here. So this length and this length is the same. So it looks like N, right, is the midpoint of that guy. So, so what do we notice about these is that Rn is going to be equal to N R prime. So they're about the same, they're the same lengths. Okay. Last question. Is what you observed for the segment R to R prime true for any segment connecting a point with an image? That is the line segment connecting a point to its image always perpendicular to the line of reflection, right? Is that line of reflection always the midpoint of our segments? Well, we don't have a whole lot to go off of, right? So all I can say is we can kind of use this same idea of thinking for, say, Q to Q prime. Again, if I come up with this point and I draw a line from here to here, that's going to be the same as that line, okay? Now, I could create triangles, right? I could create a right triangle, and I could use the Pythagorean theorem, a squared plus b squared is equal to c squared, for those of you that remember the Pythagorean theorem. So this would be a 1, and this would be a 2. So 1 squared plus 2 squared, right, is equal to c squared. So 1 plus 4 would give you 5. So c would equal the square root of 5. Now, this would be the same distance, because again, this would be 1, and this would be 2. So we can kind of think about it. We can think about it that way. So based purely on our observations, PP, or P prime, and Q prime are also perpendicular to that. So we can say P and P prime and Q prime are also perpendicular to line L. Okay. Again, reflections preserve the lengths, right? And everything. Important thing to know is that the line of reflection is at the midpoint of the line segment, or yeah, at the midpoint of, let's say, this. So of QQ prime, PP prime, and we'll say R prime. Oops. Okay. So let's take a look at 41 and see how we want to address this situation. So it says Evan has graphed the point 5, 7, and he wants to reflect it over this line that he's drawn. So he wants to predict that the reflected point will have the coordinates of 2, 2, right? So here's his random line that he drew. Here's what 5, 7 would be, and here's 2, 2. Without graphing, can we confirm his answer and show that, can you confirm his answer or show that he cannot be correct? The diagram is a rough sketch. It's not drawn to scale. All right, so if we think about this, of what we just talked about, talking about perpendicular lines, what we want to do is we want to find our slope. So we're going to find the slope between 5, 7 and 2, 2. Okay, if it turns out to be, so if it's 5 over 2, right? Let me write my 5 a little bit better. All right, then yes, 2, 2 is correct. Okay, the reason being, negative 2, 5 and 5, 2, are perpendicular to each other. Okay, so if it's not, 5 over 2, then 2, 2 is not the point. Is not the point. Okay, so go ahead and let's find our slope. So we're going to say 7 minus 2, 5 minus 2. So 7 minus 2 is 5. 5 minus 2 is 3. 5 over 3 is not the same as 5 over 2. So his point is incorrect. So incorrect point. He's at the wrong point. Okay. Let's try some translation now. Pop up to this one. All right, so looking at 42, definition of a translation. So a formal definition for a slide is known as a translation, right? So instead of saying we slide something, we do say that we translate, and we want to be specific. We translate it up, we translate it down, we can translate it left and right. All right, so again, remember that translation and transformations are two different words, right? So here we have two pictures, and we want to describe our translation, okay? So how can I go from one point to the other? All right, so if I draw this, right? So again, I'm just gonna put A right here. So it looks like I have to go down 1, 2, 3, and then I'm gonna go over to the right 1, 2, 3, 4, 5, 6, 7. So that's it. That's all I have to do. So I'm gonna say 7 units right, and I think I said 3 units down. And it doesn't matter which I do first. So I can go 7 units right first. So 1, 2, 1, 2, 3, 4, 5, 6, 7. And then 1, 2, 3. And I get to my point. So it doesn't matter which one we do first. Okay. So go ahead and pause the video and graph this on graph paper. So we're going to plot 4, 2, 1, 7, and 2, 0 onto our graph. And I've already done so right here. So again, F 1, 7, E was 4, 2, G was 2, 0. And what we are going to do is we are going to translate it the same exact way. We want to figure out what are the new coordinates. So I'm going to say 7 units right. So 7 units right. And what was it? 3 units down. Okay. All right. So we actually don't need patty paper for this. Okay. So what you're going to do is you're going to start at a point. All right. So let's start at our E point. And I'm going to go 7 units to the right. So I'm going to go 1, 2, 3, 4, 5, 6, 7. And I'm going to go 3 units down. 1, 2, 3. And I'm going to draw E prime. Let's go G. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So here's G prime. And then F. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3. So this will be F prime. So again, I connect all my points together. Using a ruler. Okay, and so I can count this. So this would be 2, 3, 4, 5, 6, 7, 8, 9. Down 3, so this would be 9, negative 3. And this is 9, 10, 11. So this should be 11, negative 1. So this is 8, 9. This should be 8. And then 1, 2, 3, 4. So 8, comma, 4 as our new points. Okay. So it's been translated the same way. So make sure that you, and again, if we needed to use patty paper to make sure that it translated perfectly, then we can. Okay, so let's come back to here. We've already done B, fantastic. All right, for the translated triangle from part B, draw line segments connecting each vertex to its translated image. What do you notice about these line segments? What does this tell you about the translated moves each point of the triangle? Okay, so what this is saying is that if let's make dashed lines. So F to F prime, G to, G prime, and E to E prime. Okay, makes a pretty picture, right? If you're in art, right? Into art and stuff like that. So what do I notice about this? I'm going to find my slope again. So I'm going to go down 1, 2, 3. 1, 2, 3, 4, 5, 6, 7. Oh, look at that. It's the same information. So F to F prime is I went down 3 and then over 7 for my slope. M for slope. Okay, E to E prime should be the same exact 3. Down 3, 1, 2, 3, over 7. 1, 2, 3, 4, 5, 6, 7. So again, it's the same slope. And then G to G prime is going to be negative 3 to 7. Again, down 3, 1, 2, 3, and then over 7. Okay, so all line segments are parallel. So that's great. They're all parallel to each other. And they're all congruent to each other as well. Okay, because if this is 3, if we created a triangle, right, and if this was 3 and this was 7, and again, this was 3 and this is 7, and again, if this is 3 and this is 7, okay, they're all going to be the same length. Okay, and again, when we translate this image to this new image, things are not going to warp. They're going to stay exactly the same. They're not going to change. Okay. All right. That's kind of what D is asking us. All right. So what I want us to do is I'm going to have you guys try this problem, number 43, on your own and draw it on graph paper. And that's it. That's the only one that I wanted you to draw. Right? So that's the one that I'm going to be looking at and see kind of what you want to do. Now, I want to point out something on this. Notice it says X to Y. It's going to change your X minus 6 to Y minus 3, right? All you're doing is you're going to take your original X value. Same thing on this one, X to Y. It's going to change it to negative X, negative Y. You're just flipping it, right? So you're going to plug in the original X, and then you're going to manipulate it. Right? So if it said, so if we say, I'm going to change x, y to x plus 1, comma, negative y, and you have an a that gave you 4, 5. That means my a prime is now going to be 4 plus 1, and then negative 5. Which means that it's going to be 5, negative 5 as my new a prime value, right? If it was, say, b, and it was negative 3, comma, negative 2, then my b prime would be negative 3 plus 1, and then I'd plug in the negative with the negative 2. So negative 3 plus 1 gives me negative 2, and this gives me a positive 2, okay? So all this is doing is telling you that you're going to manipulate. You're going to subtract, or you're going to make something become negative. So I want to see how you guys do. So please answer A on graph paper, B, and then you can answer all, I guess, on graph paper.